Hey there, this is Kevin from Happy Coding. I've been doing these little example programs. I've been challenging myself this year to make as many as possible. And I decided I was going to do something a little different tonight, and that's I'm going to try to record it while I do it. It's the kind of thing that I would obsess over and try to figure out like exactly the right setup and then never actually do it. So I'm not going to think about any of that, and I'm just going to do it and put it out there. So here we are. So tonight I gave myself a challenge of putting together one of my favorite algorithms, is that's the random walker. If you're not familiar with it, you can do like a Google image search or something to familiarize yourself with it. It's this program that starts out just as a single point, and the point kind of randomly moves around as the program runs, and over time the path of the point forms these like interesting patterns. And that's funny, some of the top results are like stuff I put out there. I guess it's probably just for me, but whatever. You can read more about it on Wikipedia, but I'm sort of like very familiar with this algorithm because it's one of my favorites. So I'm going to skip that step and just kind of go in this direction. So I'm going to start in the p5 editor here and just make sure everything's connected. I will probably hit this play button about 1 million times in the next 15 minutes or so, however long this takes. But here we are. We've got our gray screen, gray canvas, and that's our starting point. So I'm going to start by creating some variables for our little traveling point, and I'm just going to call them x and y, the x coordinate and the y coordinate of our point. And I'm going to give them some default values. Let's just start it in the middle of the screen. Y equals height over 2, so it's like the width divided by 2 and the height divided by 2 give you the center point. Background 220. This gray always seems kind of boring to me, so let's start with something a little more exciting, like a darker gray. Oh boy. And let's draw our point. Point x, y, and run. And I don't know if you can see this in the video. I can barely see it. There's a little black point right in the center of the canvas. I guess that's exactly what we told the computer to do, so it can't be upset about it. Let's maybe make our point a little bit brighter. And again, it's just a single pixel, so I don't know if you'll be able to see it in the video, but I promise that it's there. It's right there in the middle. I could make this a circle or something instead, just to make it easier to see. And there you go. All of our code is working as expected. So I'm going to change this back to point now. So that's a point, and it's not moving at all. And so the next step is to get it moving every frame. And so there are a few ways to do that, and it's kind of up to like what artistic effect you're going for, or what kind of concepts you want to explore. But for me, I am going to kind of take, I don't know, I'm going to call it a simple approach. I don't like the word simple, but it's going to be like the way I can do it without thinking about it, honestly. So what I'm going to do is I'm going to add a random value between, I don't know, let's just start out with -1 to 1 to each of the variables every frame. So the random function gives us a value that's between the arguments that we give it. So in this case, -1 or 1, which includes values like -0.25 or +0.3 or 0. The idea being, if we change the x coordinate and the y coordinate by a random number every frame, then our point will move over time. So I'm going to run this and see what happens. So I'll give myself half credit for this. Again, I still don't know if you can see the point. Maybe I should have tested that, but like I said, I'm not testing anything with the video setup, but there is a little point that's kind of jittering around. But it's not forming any lines because we are drawing background every frame. So let me move that call to background to the setup function so that it only draws the background once and does not clear it out for every frame anymore. And one of the things I'm experimenting with is my window resolution to make sure that you can see this text, but it means that you can only see like 20 lines of code, so we'll see how that goes. Anyway, let's run it again, and you can start to see that we do in fact have a point that is walking around the canvas and forming this little pattern. I think these patterns are cool. But this is a little slow, and so I'm going to play a little trick here that maybe is cheating, but whatever. It'll make it look a little bit cooler, so I'm going to go with it. And that is, I want to sort of artificially increase the frame rate. And there is a frame rate function in P5, and so I could like do something like this, but my computer, I think because of some video card settings or something, it actually won't go up beyond 60. So no matter what I put here, it won't increase to be faster than the default. So instead of that, what I'm going to do is a little trick I play sometimes, and that is I'm going to define a different draw function, and I'm going to put a for loop in here. And I always forget the JavaScript syntax for a for loop, so bear with me. And let's say, I don't know, 100 to start with. And what I'm going to do inside of this for loop is call a different function. And that function is what was our old draw function. And so this might be a little confusing, so I'm going to take a step back and just kind of talk about it for a second. So now in our draw function, what we do is we have this for loop that loops 100 times, and each of those 100 times it calls this step function. And the step function does exactly what our old draw function did. It moves the point by a random value and then draws that point. And I'm guessing I probably got some of the syntax wrong, but let's find out. Cool. So now you see that the point is navigating all over the screen, going randomly, having a good time, and it's going faster than the default, which is what that little for loop trick gave us. So honestly, this is like pretty close to what I would call like the canonical version of a random walker algorithm. And even if I just stopped here, I think I'd be pretty happy with it, honestly. It's doing that thing where it creates these cool little patterns based off of a very simple set of rules. But we can also do a couple things here to sort of take this to the next level. So one thing that occurs to me as I look at this animation is that the point will go off the screen. And so far we've been lucky enough by the random number generator that it actually has come back, but eventually it will probably just go off the screen and never come back. And that's even more obvious if you have smaller canvas sizes. So if I have something like this, then you'll see that it'll go off, and now it's gone forever. There it comes back, look at that. But this is not very exciting if it just kind of randomly goes off and doesn't come back. And so what we can do is we can either make it so that the point never goes off of the side of the screen. We can do that with the constrain function. We could also wrap so that when you go off the right side, you come back on the left side. Either one is fine, and again, it comes down to like what artistic effect you're going for. But I said like one of my goals was to keep this as simple as possible. So I think I'm going to use the predefined constrain function that comes with P5. If I didn't remember, the syntax for it, what I could do is I could go to the P5 reference and I could search for constrain and then click on it to get more information about how it works and the parameters that it takes. So constrain takes a value and then a low and a high. So I'm going to do that. So what I want to do is constrain my variables to the size of the window, right? So 0 in width in the case of x, and y will be 0 in height. Constrain 0 height. And whenever I add some code, I like to take a step back and just kind of read through it to make sure it's doing what I think it will. And as I'm doing that, I realized that I messed up the syntax, even though I just looked at it, I still forgot it. It takes 3 parameters, right? The value that it currently is, and then the minimum and the maximum that you want it to be. So taking a step back and like reading the last few lines that you wrote is a really good practice to get into. because you'll save yourself from a lot of headaches. Anyway, let's push play. And what we should see is that when it starts to go off the edge of the screen, it'll just kind of stay there. So it'll get kind of stuck, and then it will eventually turn around. And so that looks pretty good to me. I would like to see it go off on the left and the top a little bit more. What I'm going to do is decrease the size quite a bit more. Because we're using the width and height variables, it'll work no matter what the size of the window is, but I want to see it kind of get stuck on each side. So I think I'm pretty happy with that. It's gone off the top, left, right, and bottom, and it's still in there somewhere. So that's cool. I'm pretty happy with that. I'm going to make the window bigger again. So now we have constrained our point to the canvas, and we have this cool little pattern that emerges. And the next thing that I really love to play with is the color. So right now our point is just white, and again, I think it looks really cool, but random colors are my jam. So I always add them whenever I have any excuse. And if I don't have an excuse, I make an excuse, and then I add a random color. So what I'm going to do is define 3 more variables for the color components, so R, G, and B. I always forget if it's RGB or RBG. I think it's RGB. It actually doesn't even matter because I'm just going to use variables anyway. But what I'm going to do is I'm going to start this with a random color. So while I'm defining variables here, I'm going to say R equals random, and then I want a number between 0 and 255 because those are the limits of the color components by default anyway. B equals random 255. So now I have R, G, and B, and they all have a different random value between 0 and 255, and I can use that down here. So now stroke R, G, B. This will give our point a random color as it travels around the screen. So now our point is pink, but we didn't pick pink. We told the computer to pick 3 random colors, and those 3 are 3 random numbers, and those 3 random numbers equal pink in this case. If I run it again, now it's kind of a yellow, orange, like Cheeto looking color. If I run it again, it's now a really gross looking green. One of the things I like about randomness is that you don't always enjoy the artifacts that come out of it. So like I hate this color green, but that's part of the joy. Anyway, so I could leave it there, and that would be pretty cool by itself. Let this run for a while, and then print it out. Save it and put it up on Twitter or whatever. That's like the creative coding aspect of it. I've also put together like Etsy prints and stuff with this kind of algorithm. But what I want to do is like add one more little fun piece to it, and that is similar to how we're randomly walking in the coordinate space. I also want to randomly walk in color space, and that sounds a lot fancier than I mean it. Really what it means is that for every frame, I'm going to randomly change these RGB numbers, exactly how I'm changing the X and Y numbers. So let's see, how do I want to do this? Let's do it here. Let's make some space. And then what I'm going to do is exactly what I've done for X and Y, but for RGB. So I'm going to add a random number. For the point, we've done between -1 and 1 because we want the point to kind of connect to itself each step. With colors, 1 is probably going to end up being kind of too small, and it won't change very much. And I want to see a little bit of a bigger change. So I'm going to guess at around 10 being a reasonable increment. So through the power of copy paste, I'm just doing the same thing for R, G, and B. I could probably like put this out in a function or something, but whatever. And I'm going to do the same kind of constraint for the color variables as well, just to make sure that they don't go into negative or above 255, because who knows what'll happen then. You can not do that if you are curious about what actually happens. So anyway, let me constrain R between 0 and 255, and let me just copy paste the same thing for R, G, and B. Like I said, there's probably a smarter, more organized way to do this, but I just want to get something working. So Now, like I mentioned earlier, what I like to do right before I hit play is just kind of run through the code in my brain just to spot any typos or anything like that. So I create my RGB, I set them to a random value between 0 and 255, and then for every step after I move the point, I move the R, G, and B, and then I constrain the R, G, and B. And they all match up with like R and G and G and B and B, so I haven't made any typos like that. So I would bet myself $1 that this will work. And it is working, although it's changing maybe a little more than I would like. It's kind of just too random. So at this point, I do have like a complete program that I'm pretty happy with, but now comes the next step of just kind of tweaking it, and that process can honestly take, there's no limit to that. It could take freaking years if you really get into it. But I'm just going to give myself, maybe 1 minute to play around, and then we'll call it a day. So if instead of increasing or decreasing the color values, whatever these are called, color components, by 10, I'm going to go back on what I said earlier. I'm going to decrease to -1 and 1. Let's see what that looks like. Yeah, see, so like 10 seems like it was too much. This 1 seems like maybe it's not enough. It's all artistic, it's all subjective, so it kind of depends on personal preference. And actually, I'm going to increase this while I'm at it, see if I can make my computer explode. You probably just heard my computer's fan turn on. Sorry if that's annoying, but actually, I kind of like this. Between -1 and 1, I think this makes a cool little pattern. Yeah, so I'm going to stop there. Let me just, for fun, let's see how much I can increase this without like my lights dimming. Oh yeah, you can see that now like the actual frame rate is suffering because each frame, now I'm drawing 10,000 individual points, and yeah, my computer can't keep up, so the actual frame rate is much slower. So sorry, computer, before your fan gets even louder, I'm going to decrease you again. Anyway, so that's kind of where I would end. I'm pretty happy with this, and you could play around with it. There are a bunch of things you could do. Just for example, like instead of going through every single color, we could make it, I don't know how we're feeling today, let's make it red. So now instead of going through the whole rainbow, now it'll just stay shades of red, because we have limited the stroke. When we call the stroke function, we're only giving it the red, and the G and the B we're keeping it 0. We could go the other way, do something like make it blue and some red, so maybe it'll become purple, because red and blue mixed together is purple. So you're kind of bouncing back and forth between purple, which is when R is 255 and B is 255, and just pure blue because we're always passing 255 here. Point being that from here you could do a lot of different tweaking. You could try something like making the point bigger, make a circle or a square or something. You could play with, what happens when the point goes off the screen. Lots of different things you could do like that. But I'm going to put it back to old reliable, what I had before. Again, I hate that shade of green, but through the power of random, it'll eventually get prettier. There it is, nice and pink. The last thing I want to mention is, I mentioned that this is one of my favorite algorithms. It's actually probably my favorite algorithm, and the reason for that is it demonstrates this really beautiful principle called emergence, and that is, we started with a very simple rule set. Like every step, you move the point a little bit in a random direction, and that's something you can explain in like a single sentence pretty easily, I think, but without seeing this end result, it's really hard to explain what's so cool about it. If you say, oh yeah, and after a lot of steps, it just kind of looks like a big scribbly line. Like, that doesn't really sound that interesting. But it actually is, because of the way that the system sort of interacts with itself, this point going all around the screen, it generates these really beautiful, really interesting patterns in ways that seem like they might have some artistic pattern to them, but really it's all just down to randomness. And you see this kind of principle of emergence in lots of different things, like ant colonies, where every single individual ant is following a relatively simple set of rules. But if you zoom out a little bit and you look at the ant colony as a whole, it's quite complex and quite beautiful. And not to get too grandiose, but like the human brain is another example of this, where each neuron or synapse or whatever the little tiny little cells in your brain are called, they're relatively simple. They go by a set of rules that I think we have a pretty good understanding of. But if you zoom out and you look at the brain as a whole, we haven't even begun to understand all the beauty and the complexity of that. Anyway, I could ramble about that forever, but instead I will say just Google the word emergence, not emergency, but emergence, and find this Wikipedia page. And it's one of my favorite Wikipedia articles, and it goes through and talks about everything that I kind of just rambled about in ways that I probably would not be able to. But there's all kinds of examples of this in nature and in just economics and the internet and architecture and all these things. I think it's really cool, and that's one of the reasons I really like this random walker algorithm, because you can sort of see the effect of emergence directly in code that you wrote, and I think that's really cool. And if none of that makes any sense or none of that sounds really compelling, at least you have something that looks cool at the end, and really that's kind of all I care about. All right, I'm going to call it there, and thanks for watching. This is the first one of these I'm going to do. I don't know if I'll do more. We'll see how it goes. I don't know where this is going. I don't have any big plans. A lot of this video is me testing things out, so if you did watch, please let me know any feedback you have, from the size of the window to whether you could hear my computer fan too much, or me typing was annoying, or anything really. I'm very open to suggestions on how to improve. I'm going to keep doing these. I think it was kind of fun. Anyway, I'm going to call it there. Thanks everybody, and happy coding.